Hello students! Welcome to a little bit of a change of environment here. We're in my apartment and I tried to make myself a little studio here. It ain't great, but it's what we have to work with. Luckily today's lab is a little simpler than the last couple we have done. Okay, so to start off with, you guys have done a great job on your labs previously. Thank you for putting them all into Canvas. That was fantastic. So much easier for me to grade. I really appreciate that. Additionally, if there are any more questions about weather station models, feel free to let me know. I did see some confusion, especially when it pertained to turning the pressure numbers into the actual numbers that were required on the weather station model. I didn't see so much about the model numbers going from the model to the pressure. You all did a fantastic job with that. But if you guys have any more questions, let me know. Remember that along with this video, I will be posting within the notification on Canvas a weather for a certain day. Do not assume it is today, but it will be a weather for a certain day at a certain place, and you will be able to make me a weather station model for extra credit. Do not be afraid to do so. Do not be afraid to ask me questions. Even though it is extra credit, I am doing this so that it is easier for you once the final rolls around for you guys to do this. Okay, so talking about the final. The final will be next week. I do not mean to alarm any of you, but the final is going to be open on the 13th of April, and it will close on the 17th of April. So what that means for this lab in particular is this lab is due before you take the final. Please, at some point, turn this lab in and then take the final. This is the lab that you will want to go through and you will want to understand before getting to the final, as there is something on this final that you will have to know how to do. Okay, additionally, I will be posting a video later in the week that will be reviewing a lot of the material that we've had in class. This material will be popular questions that I have had throughout the semester about the material we've covered throughout the semester. I say the second half of the semester. This is not cumulative. The final is just everything that we have learned from the midterm to the final. I will be posting a review video in lieu of the fact that I cannot hold review sessions. So, if you have something that you would like me to cover in the review video, please, please, please let me know. I will happily cover it. Feel free to ask me any question and say, Mr. King, I would like you to go over this. I will do so. I will be taking the time to create a video, and this video might be long. I am sorry for those of you who have to suffer through hearing my voice for another. It might be long. But what I will do is I will step all of you through the material that we have done little by little. I would expect to see that at the latest Sunday. I would expect to see this by the latest Sunday. I'm going to try and get it filmed on Friday. I'm not sure how well that's going to go, but I would look for that on Sunday, maybe Saturday. Here's hoping. I don't know. It'll be somewhere around there. All right. With that out of the way, I think that's all the housekeeping things we need to do. Cover the final, cover this lab when it's due. Again, this lab is due when you take the final. I'm going to make the due date the last day that you can take it. Please turn this in to me before the final. Again, it would really behoove you to do this lab before that. All right, let's get into our lab. So this video isn't half an hour long. Turn to page 83 in your lab manual. You will see that we are almost through this. And you'll be at lab exercise 9, and we are going to talk today about climographs. All right, so on page 83, it should look like this. This is where you should be right along with me. You'll see a bunch of letters and stuff next to them here. We talk about climate versus weather. And you will have that outline for you where weather refers to the daily atmospheric conditions, where climate refers to what they have here as a 30-year moving average of weather conditions. So weather is what's going on right now. Climate is what is typically going on right now. That does not mean that every year will follow that same pattern. All right. So you will see, as we get into this page, you will see the primary classifications. Those of you who have taken Dr. Cicchetti's Physical 1 class, he will probably have furnished you with a fantastic, very abbreviated paper for this, which the lab manual does not give you. Feel free to use that. I also have a copy of that, but as it stands right now, for those of you who do not have Cicchetti, we will be using what is in the book, what is in the lab manual. I will do my best to step you through it. And again, remember, if you have any questions while you are doing the lab, feel free to let me know. Feel free to hit me up. You can text me. You can email me. I have been doing my absolute level best to answer every question and every email that comes my way. So please know that if you need some help in anything that pertains to this class, I can do that. Okay. So you will have to read about the Koppen Classification that is down here at the bottom, and it starts off with the primary classifications, the A, B, C, D, and E, and the A classifications are your tropical climates. It also defines them as megathermal. Your dry climates, which are your arid or semi-arid, which this gets you your deserts or even some areas of the tundra experience this. Your subtropical is the C, continental is D, and polar is E. If you recall, back to the previous lab, we talked about the air masses, the weather systems. You will see a lot of the terminology that was used in that lab is also used in this one. You'll see a lot of parallel there. While they are not the same thing, you will definitely see some parallels here. Okay. So we know that Koppen Classification, when you write this down, when you denote the Koppen Classification of an area, it will be typically 3 letters. It will be 1 uppercase letter, which is the primary, and then you will have 2 lowercase letters, which will denote the other types of weather that occur within that climate. For example, what you're going to hear me, I have made a chart that I will show you later about my hometown of Philadelphia, Pennsylvania, and I will be stepping you through how we classify Philadelphia on the Koppen Classification scale, and then showing you how we can represent that in a visual fashion. That will be the culmination of this lab. All right, so if you turn to page 84, it will start giving you, you'll see a practice down at the bottom. Again, I highly encourage you to read this. Because each one of these will provide you with a different approach. This is one of those lectures that is really hard to apply blanket statements to, because each one of the questions that you'll be getting, the data sets, if you will have a different standard. You'll be looking for something different to help define what they are. Koppen Classification, you will sometimes be working from backwards to try and find the primary, or you will occasionally be working from the primary trying to find the corresponding letters after that. But each one of them has a certain classification below them. You will see on pages 85, 86, 87, and there's quite a few of these, through page 90, it defines the different classifications. So here's what I'm going to do. So on the practice on page 84, it will say, using table 9.1, identify the climate associated with the data below. So what it's going to do is it's going to give you a line for temperatures, and it's going to give you a line for precipitation. And you're going to have to use those 2 data sets to try and figure out which one of these classifications this goes into. All right, so if we look at the data set down at the bottom of page 84, you may have to do a little math here. If you harken back to the statistics lab that we did a few weeks ago, you will have a data set, and you may have to find some averages of these numbers. But if you kind of look at the spread of numbers, you will see that, like, the precipitation here, looking at the precipitation, you will see that it averages between 2.9 to 4.0 inches of rain per month, which is not a very varied total. There is not a whole lot of variation there. So you will know when you go into the Koppen Classification that it gets pretty equal amounts of rainfall throughout the year. So what you're going to do is you are going to look at those numbers, and I have had a chance to go through this, and I'm going to step you through it. Okay, so the one thing you'll notice is you will first look at the temperature. So if you're looking for an A, you will see the tropical average temperature of the coldest month is above 64. Okay, you see the coldest month is not above 64, so you know it is not an A classification. Okay, so you will have a B. If you look at the B climate, let's look at that one. It'll say the rate of evaporation exceeds precipitation. The separation of dry climates from humid is determined by comparing the total annual precipitation to a value. Okay, all right, I'm going to stop this here. Okay, so the B classifications tend to be dry. If you do not see a lot of rainfall, it is most likely a dry classification. Again, this has its exceptions. Like I said, it's very difficult to apply a blanket statement to this lab. So what you want to do is you want to try and rule out certain things. So what we're going to do is look at the C. So we've ruled out A. We know this is not a dry climate because we've seen the precipitation is pretty consistent. There's no months where it has little to no precipitation. And you're going to go to C, and you're going to see C says a moist, mild winter. Average temperature of the coldest month is below 64 but above 26. If you look at the data set on page 84, down at the bottom, you will see that that fits perfectly within this classification. So given that the other two classifications are the humid continental and subarctic, you know that the temperatures do not qualify as subarctic or arctic temperatures or polar. You will see that C is indeed what you're looking for. All right, what you're going to do now is you're going to look for, you have the possibilities of it being an F, a W, or an S as the middle letter. So you're going to look at that and you're going to see that the F is moist with no distinct dry season. It says precipitation is evenly distributed. That sounds right, but we're going to continue here. W says a summer is rainy, but a winter is dry. And then you have an S, which is a winter is rainy, but the summer is dry. We know from when I first said it that this is most likely an F because the precipitation is very evenly distributed throughout this. Okay, and last we have to find the last letter of this, and since we know it is C and we know it is F, we continue working down that chart. So we have A is a hot summer with the average temperature of the warmest month is 71.6 degrees or higher, with at least 4 months with 50 degrees or higher. There's a cool summer, which is an average temperature of the warmest month is under 71, and a cool short summer, where the average temperature of the warmest month is under 71, but 1 to 3 months with averages of 50 degrees or higher. So we look at that, and we know that it does get warm summers. We see that. So it would be a C, an F, and an A. All right. Okay. So that is one of the processes that you will be using to find the Koppen classification. Again, I feel the disclaimer needs to be said with this lab is that there is no 100% foolproof way to approach this. There are times where you will have to work backwards, where you will have to look and see, okay, well, how much rain does it get over the summer, or how much does the temperature vary throughout the year to help you apply this. If you feel that something is not right, again, if you are doing your lab, and I think you're going to have to do, 3 of these, I believe? Yes, there are 3. Do not be afraid to hit me up for help. I am here if you have questions about this. I know this is very confusing, and you are going to have to use the charts that are within the lab to kind of play detective. You're kind of playing the part of the amateur climate scientist here for a lab, and you are going to have to figure out which one of these data sets fits into that chart. So if you have any questions about that, please let me know. All right, so the culmination of this lab comes to creating a climograph. All right, so a climograph is a way for a scientist to show both the average temperature and the rainfall of each month and then properly plot it on a graph. You will see on page 91 that there is a climograph for New Orleans, Louisiana. All right, so I have done my own climograph of my hometown of Philadelphia, Pennsylvania. My wife has made fun of this mercilessly, but listen, I'm not an artist, so I have made a climograph for my hometown. And as you can see down at the bottom axis, throughout each month, I have shown the average rainfall for that month. So I looked at the data set for Philadelphia and created a chart with the months on the x-axis, and there are actually two y-axes here. And on the first is the average inches in rainfall along this axis, and along the other axis was the temperature. We're going to take this a step at a time here. I'll tell you why I did that. So what I first did when I created this graph is I looked at the average rainfall. So I created the first part of this graph with the intent of showing how many inches in each month of rain that they got. So I plotted that and created my very janky bars here. As you can see, they're not great. Okay, but then what I did after that was showed on the other side of the y-axis, on this side right here, let me move it over here, the average temperature. So what I did was in blue, I put precipitation, as you can see here, and in red, I did the temperature. And therefore, we see what the average rainfall and temperature is for each month. Now, as luck would have it, we've already talked about the climate classification that my hometown is in. The example that we went over, it is a CFA, where we get warm summers, very evenly distributed rainfall, and our winters tend to be rather mild, I suppose, compared to other areas in this latitude. Okay, so you can see here that the temperature, we have a very warm summer, and then we have nice, cool, chilling winters. And the rainfall, again, is very evenly distributed. You will see some dips here. For example, how you would see this change throughout the world is if you have an area that has a monsoon season. So a monsoon season, you would see a few of these blue bars would have absolutely nothing. And then you would have a massive spike throughout 2 or 3 months out of the year. And a lot of the others would have very little to almost nothing. And the temperatures would probably be a lot more even across the board. Whereas if you were in a polar region, you would see that it would get more precipitation, but the average temperature would probably fall below. You'd probably see that cutting into the bars here. So that is what you're going to make. So again, just to step you through this one more time, you are going to create a graph, and it is going to ask you to do this on page 93 of your lab. Okay, you are going to create a graph, and you are going to label both y-axes with the average rainfall. The average rainfall will be on one, and the average temperature will be on the other. If you would like to color code it to make it easier, that is okay. Feel free to do that. I found it easier for me to understand if I use various colors. You probably can definitely tell from my prior videos that I am really missing the whiteboard. And then what you're going to do is you're going to plot the numbers that it gives you on this chart here, and make a little bar graph for the precipitation, and make a line graph up top here for the temperature to give you the answer you are looking for. All right, so thumbing through the lab, you need to turn into me pages 92 and 93. The data that you will need to put the Climograph together is on page 94. Just flip the page over, it is right there. That is the data you need. And you will have to tell me which classification this is, that this is going to be. Okay, again, so remember 92 and 93 are what you're turning into me. Please put your names on each of them, submit them through Canvas. If you have any problems with Canvas, please let me know, and I will do my best to help you out. Most of you who have reached out to me, I'm learning Canvas with you. So we are going through the problems together, so just reach out to me if you have anything. And the weather station models, remember that you can turn in a weather station model. With this post, I will be giving you the data for a weather station model. You will construct it, you will take a picture of it, put your name on it, and submit it to me. You can submit it with the lab, and I will give you extra credit points for doing that. Those of you who did the weather station models last time around, you did a great job. I was really happy with the overall layout that I was seeing. Again, don't forget that I don't mind if you put the arrow into the weather station model that the air is flowing into the station model. Do not be afraid to do that. That is completely okay because it shows that you at least understand the concept, understand what the station model is trying to tell you. Again, to close this out, if you have any problems, if you have any issues, let me know. You can text me. Like I said, I will get back to you as soon as I can. Those of you who have, thank you for reaching out. I'm doing everything I can to ensure that this whole finishing up our class online, which teaching a lab online is, God, I wish we could do more. So much of this would have been so much more fun to do outside. So, but let me know. Get in contact with me. I'm here. Email me if need be. But other than that, I think that is what I have. So to end this video again, pages 92, 93, and the weather station model, please put your names on all of them and submit them to Canvas.